Write an algorithm to find the greatest common divisor known as the GCD of two numbers using Euclid's method or the Euclid's algorithm. Before we proceed to find the greatest common factor or divisor between two numbers, we need to first understand what is GCD. Let's take a few examples. We shall really know it. Suppose my input number is 10 and 20. The only common divisor between 10 and 20 is going to be 10. So my greatest common divisor is 10. Suppose I have the number 7 and 5. The greatest common divisor is going to be 1. Suppose I have my number, let's say 100 and let's say 80. The greatest common divisor is probably going to be 20 in this particular case. So this is how you proceed to find the greatest common divisor, or what is the greatest common divisor. Let's see how this algorithm really works. So we will read two numbers into A and B. For simplicity, we are assuming the bigger number is in A and the smaller number is in B. Okay. So first we are going to read two numbers, input A comma B. Let us input number say 90 here, and in B let's input 80. Now remainder doesn't have any value, it doesn't matter in the beginning. As long as this particular B is not equal to 0, we shall continue to execute the while loop. So this GCD calculation step 3 is the most important step. So as long as B is not equal to 0, the first step I am trying to do is I am calculating remainder, which is A divided by B. What is the remainder? If I divide 90 by 80, the remainder is going to be 10. So remainder happens to be 10. This fellow is still as it is, and let's see what happens to A and B in the next step. A takes the value of B, so A becomes 80. And what happens to B? B takes the value of the remainder, which happens to be 10. Now the while loop has ended and I'm checking at the value of B. B is still not equal to 0. So remainder is 80 mod 10. Now 80 divides 10 perfectly. Okay, or 80 is divided by 10 perfectly. So the remainder happens to be 0. You can verify it like this. Okay, this is 10, this is 80 into 8. The remainder is 0. Since the remainder is 0, so this remainder is now 0, 0. So what happens is remainder is 0. A takes the value of B and B takes the value of remainder, which happens to be 0. Now when we go back to the loop, B is not equal to 0. This condition fails because B is definitely equal to 0. Since B is equal to 0, what I am expected to do now is I am expected to come out of this loop and just see what I am doing. I am printing the GCD is the value of A, or the value of the last divisor. In this case, A happens to be 10. So the GCD of 90 and 80 happens to be 10. In order to further clarify our concept, let's take two different numbers where the GCD happens to be or ends up coming to be as 1. Alright. So let's try to experiment on that one. So I'm taking A as 7, B as 5, and I have not given any value to remainder. Let's see how things work. Now I am doing a start. I am reading two numbers. A is 7, B is 5. Remainder, I don't care what is the value. Now I come into this loop. Okay. These are set of statements which are going to be executed again and again as long as the value of B is not equal to 0. 7 mod 5. Okay. So if you try to divide 7 by 5, the remainder happens to be 2. Now what happens? A takes the value of B. B takes the value of remainder. Now this fellow 2 is not equal to 0. So I come back here. Okay. Now what is A mod B? 5 divided by 2, the remainder is 1. A takes the value of B, which happens to be 2. B takes the value of remainder, which happens to be 1. Now again I go back. B is still not equal to 0. Remainder is equal to A mod B. If I divide 2 by 1, 1 2s are 2, and the remainder is going to be 0. So now what has happened in this case? Remainder has finally become 0. Let me write it at this step. Remainder has become 0. Once remainder has become 0, A takes the value of B, which is 1, and B takes the value of remainder, which is 0. Now if you see here, B is equal to 0. 0 not equal to 0 is false. So I am going to come here and I am going to print the GCD of 7 and 5. The GCD of 7 and 5 is going to be the last divisor, which happens to be 1. So 1 is the output and 1 happens to be the common divisor between 7 and 5. So just try out this with different numbers and you should be perfectly fine in understanding this logic.